Hello, Math 2 students. I hope you're ready for an introduction to factoring polynomials. How to change a polynomial from standard form to factored form. What do you already know? Well, we know how to use the zero product property to solve an equation that is in factored form. In this example, we have an x in front of the parentheses, and that will tell us that we have an answer of x equals 0. In the second set of parentheses, we have an unwritten 1 for our coefficient, so we can just use the opposite and our answer will be x equals 6. And finally, we have in parentheses a coefficient of 3, which means we need to work out this equation to find out what the solution is. So I add 7 to both sides, and I have 3x equals 7. Now I divide by 3, and x equals 7 over 3. So we know if we substitute in 7 over 3 for x, or if we substitute in 6 for x, or if we substitute in 0 for x, all three of those x values will make the left side of the equation equal 0 to match the right side of the equation. We also know how to use the greatest common factor to change an equation into factored form and solve the equation using the zero product property. So in this first example, we have two terms, and both of those terms have an x in them. So we're going to want to put this equation in standard form. So I'm going to subtract 25x from both sides, and I will have 5x squared minus 25x equals 0. And now I look for the greatest common factor, the biggest number that goes into 5 and 25 evenly, and that number is 5. And each part of the equation has at least one x. So we have 5x as our greatest common factor. And when we do the reverse distributive property, 5x times x is 5x squared, and 5x times negative 5 is negative 25x. So now written in black, that is our same equation that we started with, but now it's not in standard form, it's in factored form. And using the zero product property, just like we did on the first example, we find out that x equals 0 because of the x in front of the parentheses, and x equals positive 5 because of the term inside the parentheses that has a coefficient of 1. In this third example, we have an x squared value, a constant value, and a constant value. So on this type of an equation, it's better to just isolate the x squared and not worry about putting it in standard form. So I'm going to subtract 3 on both sides, and I will have x squared equals 19 minus 3, which is 16. And I have to think what number multiplied times itself will give me 16. Well, that number is 4 times 4, which could be 16, or negative 4 times negative 4, which could be 16. So the solutions to this third example are 4 and negative 4. Now we need to take a closer look at standard form. On the last two examples, the second example that we looked at had two terms and they both had x's in them. In the third example, there were 3 terms. One of them was an x squared term and 2 of them were constants. Now we're going to be working with equations that we need to put in standard form that have 3 terms. An x squared term, an x term, and a constant term. So on this first example, I'm going to subtract 2x from both sides, and I'll have 3x squared minus 2x equals 11. Then I'm going to subtract 11 from both sides, and I will have 3x squared minus 2x minus 11 equals 0. Now on the left-hand side of the equation, all of those things are not like terms. There are 3 terms, and they all have different exponents. So we cannot put any of them together. To be like terms, you have to have the same variable with the same exponent. Now, we're going to start talking about things with some different names than we have in the past. The x squared term, whatever the coefficient is, that's what we're going to call the a. So the coefficient on our x squared is 3. So our a term is 3x squared, and our a value is 3. Our b is -2. And so the x term, whatever the coefficient is, that's always called b. And our constant term is c, which is -11. So from now on, we'll be talking about our a term, our b term, and our c term. And the only way you can know what your a term, b term, and c term are if you put the equation into standard form. So in our next example, I'm going to subtract 4x from both sides. And I'm going to write it in standard form. So that'd be x squared, then minus 4x. Then my constant term always comes last, and that equals 0. So now that is a second degree trinomial, and it's in standard form. My a value is an unwritten 1. My b value is a -4. And my constant term is 13. So from now on, we're going to need to put our equations in standard form, and we're going to need to be able to identify what our a, b, and c term are. Your a term is always the coefficient on the x squared. Your b term is always your coefficient on your x, and your c term is always your constant term. The big idea in chapter 2 of our textbook is to be able to solve a quadratic equation, an equation that has an x squared in it, by turning standard form into factored form and using the zero product property to solve that equation. Today, we're not going to make it all the way to that big idea. Today, what we're going to do is we're going to learn how to factor. And so you can see we have x squared plus 7x plus 6, but it's not an equation. There's no equal sign. There's no 0 on the other side. This equation or this expression is still in standard form, but all we're going to do is we're going to factor it. We're not going to have to worry about solving for x. So what is factoring? If you look at the red writing on the screen, where we started in this chapter is we started learning how to multiply a binomial times a binomial. And so we would use a table or the distributive property or sometimes FOIL, and we would multiply x plus 1 times x plus 6. Today, what we're going to do is the reverse of that. So we're going to call this the reverse of foiling. So we're going to take our x squared plus 7x plus 6, and we're going to try to turn it into a binomial times a binomial. And if we do the problem right, if we factor it correctly, when we multiply our two binomials together, the answer will be x squared plus 7x plus 6. So if we go back to the red writing again, and we do the problem, x times x is x squared, x times 1 is x times 6 is 6x, and 6 times 1 is 6. And then we have two like terms, and so when we take everything out of our table, we'll have x squared plus 7x plus 6. So you can see the red writing is the answer to our problem that we're doing today. These two binomials give us this second degree trinomial. But on the problem we're doing today, we're starting with the second degree trinomial and we're looking for the binomials. And as you can see, our answer is obviously going to be x plus 1 times x plus 6, but we need to find out how that works. So the first thing we're going to look at is we're going to look at our firsts. So those are our firsts. And we know when we multiply the firsts together that our answer is going to be x squared. So our firsts multiplied together give us x squared. What two things can we multiply together so that their answer is x squared? Well, it's going to be x times x. So our firsts, our x times x, is going to give us x squared. Now we're going to take a look at our lasts. So our lasts need to come out to 6. So we have two choices here. We could use 2 times 3 is 6, or we could use 1 times 6 is 6. I'm going to intentionally do the problem the wrong way right now. So I'm going to put a 2 here and a 3 here. And that does give us an answer of 6. But it's very important for you to see why this is not the right answer on this problem. And the reason it's not the right answer has to do with the O, the outers, and the inners. On our problem, the outers and the inners, when we put them together, need to combine to 7x. So right now, if I multiply the outers, I will get a product of 3x. And if I multiply the inners, I will get a product of 2x. And when we combine that 3x and 2x, if one of them is positive and one of them is negative, we'll get 1. But we're looking for 7. And if they're both positive, we'll get 5. But we're looking for 7. So even though 2 times 3 is 6, 2 plus 3 is not 7. We're looking for a combination of numbers that multiply to 6 but add to 7. And 2 times 3 is obviously not the only way to get 6. If we use the numbers 1 and 6, our lasts, 1 times 6, will still be 6. But when we multiply our outers and our inners, our outer will be 6x, and our inner will be 1x, and 6x plus 1x is 7x. So as long as we have a positive 6x, so I'm going to put a plus sign in front of the 6, and a positive x, I'm going to put a plus sign in front of the 1, then when we FOIL those two binomials, or when we multiply them, our answer will be x squared plus 7x plus 6. And that is exactly what we had when we started the problem. So the answer to this problem is these two binomials. The binomial x plus 1 multiplied by the binomial x plus 6 gives us x squared plus 7x plus 6. So those are our factors of x squared plus 7x plus 6. Our goal on this problem is to find two binomials that, when multiplied, give us w squared minus 4w plus 3. So we're going to try to figure out two binomials, and when we multiply those two binomials, we want the answer to that multiplication to be w squared minus 4w plus 3. We're going to do this by reverse foiling. So we know that our firsts, these two terms right here in our binomial, need to multiply to w squared. So we know that our first is w squared, and the only way to get w squared is by multiplying w times w. We also know that our lasts in our binomial are going to multiply together and give us this 3. And this is an easy problem in one way because 3 is a prime number, and the only way to multiply and get a last of 3 is by multiplying 1 times 3. So the final thing that we have to worry about in this problem is our O and our I, our outer and inner term, need to add up to the middle term of our trinomial, which is negative 4w. So in this problem, we just need to make sure that the signs are done correctly. When we look at our outers, we get 3w, and when we look at our inners, we get 1w, and we need those two like terms to add up to negative 4w. So we need a negative 3w, so I'm going to put a negative sign in front of this 3, and a negative 1w, so I'm going to put a negative sign in front of that 1, and that should be the answer. That should be the binomial that gives us the product w squared minus 4w plus 3. But I'm going to come over here and do a table check to make sure that we have the problem right. So I'm going to take my two binomials, and I'm going to put w minus 1 here and w minus 3 here, and I'm going to multiply them, and I get w squared minus 3w minus w plus 3. And when I take that out of the table and put the like terms together, I will have w squared minus 4w plus 3. And as you can see, when we multiply those binomials, we get our original problem for the answer. So we know that the answer to this question, the two factors of w squared minus 4w plus 3, are these two binomials right here. The challenge on this problem is to find two binomials that multiply together and give us the product y squared plus 13y minus 30. So we're going to set the problem up. Here are our two binomials. And we're going to do reverse foiling. So there's our firsts, our outers, our inners, and our lasts. And on this problem, we know that our firsts need to multiply together and give us a y squared. So our firsts are going to give us a y squared, and the only way to make that happen is if this term is y and this term is y. So our firsts are taken care of. Our lasts need to multiply together and give us our constant term. So that's negative 30. Now, this problem is the most difficult one that we've tried so far. In order to get 30, we could use 1 times 30, or 2 times 15, or 3 times 10, or 5 times 6. All of those could multiply to 30, but we need them to multiply to 30, but either add or subtract to 13. So I'm going to start out by intentionally doing the problem incorrectly. It seems obvious that 3 times 10 is 30 and 3 plus 10 is 13. So I'm going to go ahead and put a 3 here and a 10 here. But when we check our outers and our inners, we need our outers and our inners to add up to positive 13y. And so our outers are 10y and our inners are 3y. But we have a problem. We need it to multiply to negative 30. So the only way to multiply to negative 30 is if the 3 is a positive and the 10 is a negative, or if the 3 is a negative and the 10 is a positive. So these signs, the sign of the 3 and the 10, in order to add up to 13, they need to have the same sign. But in order to multiply to 30, they need to have different signs. And so on this problem, the combination of 3 and 10 is not going to work. We're not going to be able to get them to multiply to 30 and add to 13 with the configuration of signs that we have in the problem. But lucky for us, there's another way that we can multiply to 30 and either add or subtract to 13. And that's by using 15 and 2. So if we put a 2 here and a 15 there, our lasts will still multiply to 30. Our outers will be 15y, and our inners will be 2y, and we need our outers and inners to add up to positive 13. Well, to make that happen, we'll just make our 15 positive and our 2 negative. So we'll have a negative 2 here and a positive 15 there. So now if I do a table check with my binomials, y minus 2 and y plus 15, I will have y squared plus 15y minus 2y minus 30. So when I take that information out of the table, I'll have y squared plus 13y minus 30. And if you notice, that is exactly the same thing that they gave us in the problem. So my two binomials, y minus 2 times y plus 15, those are the two factors that I'm looking for.